Hello and welcome back to my channel. Today we're going to be talking about optimization, which is a technique to find the best possible solution in a given situation. So a lot of times with optimization, it's going to be similar to related rates in the fact that we have been given a situation and we kind of need to figure out an equation that's going to go with it. We may need to draw a picture, things like that. The way that it's different is that we're going to be finding our maximum or minimum. So we're going to be using those ideas that we've been working up to in this unit to kind of help us out with that. So steps that we can follow. Draw something that's going to help. Sometimes this is a picture, sometimes it's not. Sometimes we can't draw anything. We need to write an equation to find what we want to optimize. Sometimes we might want to use words to kind of help us out. Use the information in the problem to rewrite the equation into one variable, generally the thing we want to optimize. Find any critical values, find out if we have a maximum or minimum, and then rewrite the answer in context. So, you are working to enclose a rectangular garden with a fence. One side will be along a house, so it does not need a fence. You have 50 feet of fencing. What are the dimensions of the largest garden you can enclose? So the first thing we're going to do is we are going to draw a picture. So I have this side right here. This is going to be the side of the house. And then we need our fence. So our fence is going to be made up of the rest of these sides here. So when we're looking at this, one thing that we notice is that we really only have 3 sides of this fence that we're going to be dealing with. It says we want the dimensions for the largest possible garden. This is a rectangle, and we want to look at the largest possible garden, which means we're going to be talking about area. So we want the area equation. So our area is equal to length times width. Okay, so it doesn't necessarily matter which one's length and which one's width, but we need to pick one for our problem. So what we're going to do is we're going to make one of those sides x, and then we're going to figure out what the other side is going to be. Because we have 2 of the same sides, I'm going to make the side that we have 2 of x. So if that side's x, that means this side's x. And then we need to figure out what that third side is. Well, we have 50 feet of fencing total, so the max that our side can be is going to be 50. And then we're going to subtract the amount of fence we've already used. Well, we have our 2 sides that are both x, so that's 2x. So our 2 sides of our fence are x. That third side is going to be 50 minus 2x, and that's going to make up our whole fence. So we have our length and our width. Well, one side is equal to x, and the other side is 50 minus 2x. So what we're going to do now is we are going to make our lives easier by multiplying that x out to both things. So 50x minus 2x squared. And this is the equation that we want to deal with. So now we're at the point where we want to find our critical values. So we're going to take our derivative. So we have 50x minus 2x squared. So we have 50 minus 4x. So now we need to find our critical point, so we're going to set this equal to 0 and solve. So 0 is equal to 50 minus 4x, and then we're going to solve for x. So I get that x is 12.5. Okay, so now we need to figure out, is this a maximum or a minimum? Because our critical point doesn't tell us it is necessarily when it's just saying, like, this is where our derivative gives us a slope of 0, or this is where our function has a slope of 0. So we need to decide if it's a maximum or minimum, and we can do it in many different ways. Because we want this to be the largest garden possible, we may want to do the absolute maximum or minimum, but you could also do our increasing versus decreasing to decide what it's going on. We just need to do something. So if I want to do absolutes, I'm going to look at our critical point and our endpoints. So our endpoints are going to be the smallest and largest our sides can possibly be. So the smallest our one side could be is 0. This would give me this side right here a length of 0. The smallest this side would be when it equals 0, so it would be 25. So in order to find those two values, I just figured out what would make the sides of my rectangle equal 0, because after that, we don't have a fence anymore. So the side we care about is that 12.5. So then what we're going to do is we're going to take these values and we're going to plug it back into our a of x equation, either one. I'm going to plug the endpoints into that first one, that factored form, this one right here. 0 times 50 is 0. And then we have 25 times 50 minus 2 times 25. Well, 50 minus 2 times 25 is 0, so 25 times 0 is 0. So I know that those are going to be the smallest that we can possibly have it. And then we're going to look at 12.5. So if I plug in 12.5 into my function, 12.5 times 50 minus 2x. So 50 minus 2 times 12.5 is going to give us 25. 25 times 12.5 happens to be 312.5. And if I look at this clearly, 12.5 gives us the largest value. So our maximum is 312.5 feet, squared feet. And that happens at x equals 12.5. So now we're just going to finish up with our statement. So the largest, and we want to remind ourselves, we want the dimensions of the garden. So dimensions being, we want these side lengths next to each other. So the largest dimension of the largest garden we can make is 12.5 feet, that x value we got, by, and this is where we would put in our x values, so that 50 minus 2x, which we know is going to simplify to 25, so 12.5 feet by 25 feet is going to be the largest dimensions.